Hello guys, I hope you're doing well. Welcome to my YouTube channel, which is Data Science Gurus, and today we are going to start a complete course which is related to machine learning for beginners. In this course, we will discuss everything in detail and also the implementations. Um, for Python, like I'm going to explain every single thing, like practical implementations, the algorithms, and how they work, and the implementations in Python. So the name of the course is Machine Learning for Beginners with Python Implementations. Okay, you can have the code and you can have everything with you, and you can implement it by yourself as well, and you can test the codes as well. Okay, for better understanding of machine learning. So before going to the topic, first of all, you should know that what actually machine learning is and why it is very important for us, and what are the core concepts of machine learning. So, machine learning is a branch of artificial intelligence that uses computing-based systems to make sense out of the data, extracting patterns, fitting data to functions, classifying data. Machine learning systems can learn and improve with historical data, time and experience, and bridges theoretical, computer science, and real noise data. Okay, so machine learning basically you're actually let the computer learn through the help of programming to actually do your tasks. Okay, for example, what like how we can say in practically. So for example, you have 50,000 emails and you want to classify the emails or the images or any sort of text messages into their categories. Okay, so it will, for a person, for a human being, it will take a month to just classify the emails. So how can you just classify the emails very easily and by the help of AI? So basically you are going to train the model on the parameters, and then after the parameters, then you can simply give it the input and it will give you the label, or it will give you the result for that specific class. Okay, similar cases with the images as well. So if you so when we for machine learning, the data is very important for us because the model is being trained on the data. So if you don't have the data, then you cannot train the machine learning model. Okay, so first of all, the first concept is that machine learning actually learns the features from the data, and then it gather the features, and after that it can just classify the data, it can do the predictions. Okay, so for this reason, the data set is very important for us. Okay, so uh, we can proceed. Okay, so secondly, what are actually the types of machine learning? So basically, we have three basic types: supervised learning, unsupervised learning, and reinforcement learning. Okay, so in today's lecture, we are going to discuss these three types with their proper examples, and after that, we are going to do the practical implementation for supervised learning in our next lecture for unsupervised and reinforcement learning. Okay, so these are the basic three of the classification or three types of machine learning. The first one is the supervised learning, second one is the unsupervised, and the third one is reinforcement learning. Okay, so for example, if you want to train a machine learning model, so what actually the process you have to follow for that? So first of all, you have to define your objectives. Second one is the data preparation, which is a very important step. Third one is the model building. Fourth one is model evaluation, and the fifth one is model deployment. Okay, so first of all, like, you should know the main objectives of your main goal, that what's actually the goal you're approaching. Okay, for example, if you want to train a model to classify the images between, we can take a very simple example. For example, if you want to classify the images for cats and dogs, Okay, so you have 1 lakh pictures for cats and dogs, and you want to classify them. Okay, so how you are going to do this? First of all, the first step is you should know your objectives, that what actually you are trying to do, that what actually you should know, that what actually the outcome of your complete project or complete model. Okay, after that you have, because the data is very important part of your machine learning. Okay, if you don't have the good data, then you will not get the good results. So data preparation, in data preparation we have the different steps. We do the pre-processing, we have the missing values, outliers, and normalization. We will discuss every single detail in our coming lectures. And data splitting. After that we have the model building. When we have the data, for example, if you want to classify the 1 lakh pictures you have a 1 lakh pictures, and you want to classify, it can be of human beings, it can be of different people, it can be of it can be any kind of, it can be of fruits, it can be of ships, it can be of different animals, it can be of anything. Okay, and you have the different classes, and you want to classify the images into their specific class. Okay, so you have to manage, you have to focus on the data. After that you have to do the data splitting, feature engineering, performance evaluation, and model selection. After that you have to evaluate that whether your model is good enough, where you're getting good results or not. Okay, and if you're getting good results, then this is perfectly fine. And if you're not getting good results, then you have to pre-process the data. Okay, and you have to work on your data set. And after when you have your data set, then you're having a good accuracy on different models, then that model should be considered as the best model, that if it's classifying the images in a better accuracy. So this model has the ability to classify the real world problem or real world emails. So this is how basically machine learning as a process, this is a basic process to design, to just train the model. Actually, the first step is you should know that what actually you are doing. The second step is about the data set. If you have your goals and you have your data set, then you have to study the data set, the attributes of your data set. After that you have to build a model. Then you can evaluate your model on different parameters like precision, recall, accuracy, and then you can deploy the model. You can design a web application in Django and in any other platform, and then you can simply launch your application. Okay, so the first type of the machine learning is the supervised machine learning. Okay, as the name suggests, that supervised machine learning is based on the supervision. Okay, supervised learning machine models are trained using a labeled data set. Here you can see the word we just use is a labeled data set. So you should know what actually a label is. That what is a label of any data set. Like for example, if you want to classify the images for cats and dogs, so you have a folder in which you have the 50,000 images for cat. Okay, so the cat is basically a label. And if you have another folder which is called as dog, and you have 50,000 images for dogs. Okay, so that dog is your label. So when you are training the model, you have to give you're giving the features and the label with you. Okay, for example, if you want to classify the emails or the messages, then what you have to do is, in supervised machine learning, you have to give the labeled data set. That a model will actually learns the features, it will do the feature extraction, and then according to those features it will do the classification for you. like classification, we will discuss the classification in next slide, but you should have the label data set. If you don't have the label data set, then it is not your supervised machine learning. The label data means that some inputs are already mapped to their respective outputs, and the training process involves first training the machine with the input and the corresponding output. So in this example, if you want to train the data, or if you want to do the if you want to train a model that classify the images for cats and dogs, that you have to give the label and also the images, so that it can extract the features from the for cats, and then it will with the label cat, and it will extract the features from the images with the label dog, and then it will do the classification. And after that, you will give the model the you will give it another image which is an unseen image, and it will give you the label. This is called as testing. When you have the trained model, you can test it on any image, okay, and any real world image, and it will show you the results, that whether if it's actually a cat, and the model also gives you the results for the cat, then your accuracy is pretty good. If it was a cat and your model is not enough trained on the parameters, then it will give you a wrong input. It is possible that it can give you a wrong input, and it will give you uh, the wrong output, okay, like that. Okay, the machine is then asked to predict the output using a test data set. So we have the training data and we have the testing data. The training data is labeled and the testing data is not labeled. So what you have learned is, in supervised machine learning, you have the training data and the testing data. The training data is the label data, which label means that it has, in supervised learning, we are actually giving the model as a label data set, okay. And okay, so let's take an example. Let's illustrate with example. Suppose we have the data set of cats and dogs. We first provide the training to the machine to understand various features of the images, such as the shape and the size of the cats and dog tails, the shape of the eyes, their color, their height. Dogs are typically taller, cats are typically smaller. Once the training is complete, we input an image of a cat and ask the machine to identify the object and predict the output. The machine, now well trained, checks all the features of the object, such as height, shape, color, eyes, ear, tail, etc., and it will recognize that image is a cat, and categorizes it accordingly. The process illustrates how a machine identify object in supervised learning. Okay, in supervised machine learning, we have two subtypes, which is called as classification and regression. Okay, so what actually a classification is? Classification algorithms are used to solve the classification problems in which the output variable is categorical, such as yes or no, male or female, red or blue, cat or dog. Obviously, the classification algorithm predict the categories present in the data set. Some real-world examples of classification algorithms are spam detection or email filtering. Okay, so here you have, in classification, if you're classifying the objects, classifying the emails between different categories, it is called as classification. And if you have the two classes, then it is called as binary classification. And if you have more than two classes in your machine learning model, then it can be called as multi-class classification, because you have more than two classes. So if you're classifying males and females according to their features of the face, then you will be doing a binary classification, because you have two classes. The first one is the male and the second one is the female class. And the most popular algorithms that we mostly use are random forest, decision tree, logistic regression, and supervised support vector machine. Okay, the second subtype of the Supervised machine learning is regression. Regression algorithms are used to solve regression problems in which there is a linear relationship between the input and the output variables. They're used to predict continuous output variables such as market trends, weather prediction. Some popular regression algorithms are given below. Some simple linear regression algorithm, multivariable, and the decision tree algorithm. Okay, so in regression problem, like you're having an input and you're actually uh, you're actually finding out the relationship between the input and output variables, okay? And then you're predicting. For example, the best example here is about, for example, if you want to predict the price of the Bitcoin, so you have the previous data, and on the previous data from past 10 years, you will give the input you will give the previous data as an input to your machine learning model, and your model will get the features, and it will extract the features from the past 10 years, and it will give you the prediction for next day, for week, for a month. Okay, so the most popular algorithms that we mostly use are linear regression, multivariate regression, and decision tree regressor. Okay, so now what are the applications of supervised learning? Image segmentation, one of the best application of the supervised learning. Supervised learning are used in image segmentation process. Image classification is performed on different image data with predefined labels. For example, if you're classifying the images for breast cancer, you simply use the supervised learning. If you want to classify the different images for cats and dogs for medical purposes, um, for the networks data, you can simply use the supervised learning. Medical diagnosis, supervised algorithms are also used in medical field for diagnosis purposes. It is done by using medical images and past label data with labels for disease conditions. With such a process, the machine can identify the disease for the new patients. Okay, fraud detection is one of the best examples for supervised learning. Supervised learning classification algorithms are used to identify fraud transactions, fraud customers. It is done by using historic data to identify the patterns that can lead to possible fraud. Spam detection and filtering classification algorithms are used. These algorithms classify an email as a spam or not spam. The spam emails are sent to the spam folder. Okay, speech recognition is also one of the best example. Like the algorithm is trained with the voice data, and voice identifications can be done with this using the same, such as voice auto activated passwords and voice commands. Okay, the next type is of the machine learning is supervised machine learning. And so what is supervised machine learning? Supervised machine learning, unlike supervised learning, doesn't require the supervision. Okay, you don't have the label data set. So what is the difference between supervised and unsupervised? In supervised machine learning, you should have the label data set, and in unsupervised machine learning, there is no need of the label data set. In supervised learning, machines are trained using an unlabeled data. The machine predicts the output without any supervision. Model is unsupervised learning are trained with data that is neither classified or nor labeled. The model acts on the data without any supervision. The main aim of the unsupervised learning is as follows: the group or categories the unsorted data based on the similarities, patterns, differences. Machines are instructed to find hidden patterns inside the input data set. So let's take an example. Suppose there's a basket of fruit images which are input into the machine learning model. The images are completely unknown to the model. The task of the machine is to find the patterns and categorizes the objects into their categories. Okay, so the machine will discover patterns and discover such as color, shape differences. The machine then predicts the output when tested with the test data set. The process demonstrates how a machine identifies objects in unsupervised learning. And okay, so what are the subtype of unsupervised learning. There are two types: the clustering and the association. So what is clustering? The clustering technique is used when we want to find the inherent groups from the data. It is way to group the objects into clusters, such as the objects with the most similarities remain in one group, and the one that have the fewer or no similarities should be placed into the other group. An example of the clustering algorithm is grouping the customers by their purchasing behavior. Some of the popular clustering algorithms are given below: k-means, mean shift, db scan, principal component analysis, and independent component analysis. Okay, the second subtype of the unsupervised machine learning is association. Association rule learning is an unsupervised learning technique which finds interesting relations among variables with a large data set. The main aim of this learning algorithm is to find the dependency of one data item on another item and map those variables according to, so that it can generate maximum profit. The algorithm is mainly applied in market-based analysis, web usage mining, and continuous production. Some popular algorithms of association rule learning are a priori algorithm, ECLAD, FE, growth algorithms. Okay, so what are the applications of unsupervised learning? Network analysis. Unsupervised learning is used to identify plagiarism and copyright in document network. You can take the example for the Turnitin. You have used Turnitin. So Turnitin is working on unsupervised machine learning. Recommendation systems. Recommendation system widely use the unsupervised learning techniques for building recommendation application for different web applications and e-commerce websites. Anomaly detection is a popular application for unsupervised learning, which can identify unusual data point within a data set. It is used to discover fraudulent transactions as well. Singular value decomposition or SVD is used to extract particular information from the database. For example, extracting information of each user located at a particular location. Okay, the last one is the reinforcement learning. So reinforcement learning works on the feedback-based process in which an AI agent or software component automatically explores its surroundings by hitting and trial, taking action, learning from experiences, improving its performance. Agent gets rewarded for each good action and get punished for each bad action. Hence, the goal of reinforcement learning is to maximize the rewards. So for example, what is the example for like reinforcement learning? Like in reinforcement learning works on a feedback process in which an AI agent automatically it is exploring the surroundings, and it is getting it. The model is self-learning. Okay, and so there are basically two types of reinforcement learning: positive reinforcement and the negative reinforcement learning. Positive reinforcement learning specifies increasing the tendency that required behavior would occur again by adding something. It enhances the strength of the behavior of the agent and positively impacts it. Negative reinforcement learning works exactly opposite to the positive reinforcement learning. It increases the tendency that specific behavior would occur again by providing the negative condition. Okay, so what are the practical examples for reinforcement learning? The best example are the video games. Reinforcement learning algorithms are much popular in gaming application. It is used to gain superhuman performance. Some popular games that are use the reinforcement learnings are AlphaGo and AlphaGo Zero. Resource management. The resource management with deep reinforcement learning. The paper shows that how to use the reinforcement learning in computer to automatically learn and schedule resources to wait for the different job in order to minimize the average job slowdown. Robotics. RL is widely used in robotic application. Robots are used in industries and manufacturing area, and the robots are made more powerful with reinforcement learning. There are different industries. that have their vision of building intelligent robots using AI and machine learning technology. You can also use reinforcement learning in text mining, one of the great application of the natural language processing, and you can also use the text mining. You can also use the reinforcement learning for the text mining. So that's all for today. This was the introductory lecture about machine learning, its types, and from the next lecture we will also discuss the Python implementations. This lecture was about to just maintain, like, just build the base of the students so that they can have they know the basics of the machine learning algorithms, and after that we will do the Python implementations. So thank you so much, and we'll see you in the next video.